So the prisoner's dilemma is a famous scenario in the discipline of game theory. And game theory, we don't need to write down the actual definition of it, but game theory is essentially a way of analyzing situations where players have to make decisions and their payoffs are based on what the other players do, right? So their payoffs are interdependent, right? And again, that's kind of the theme of 10.4 is there's interdependence within oligopolies, right? And so the best way to learn about game theory is to just do it, which is why we're skipping that long, boring definitions. It's already in your textbook. The prisoner's dilemma is a famous scenario in which the gains from cooperation are larger than the rewards for pursuing self-interest. And so we're going to talk about this, and in order to do that, we have to set up a little graph here, or a little table rather, not graph. So it's going to look something like this. So over here in blue, we're going to have prisoner A. Up here in yellow, oh, I should actually, boop, I messed this up a little bit, sorry guys. Of course. I need to give myself a little bit more room. There we go. We got prisoner A there, and then up here we have prisoner B. Should be capital B since it's capital A. I don't know what I'm doing. All right, so the premise of this thought experiment is that you're in some random country. You guys there's this show Locked Up Abroad that was pretty popular for a while there, right? You're in some random country. You get in trouble with the law about something. It doesn't matter what it is, right? And you have these following choices. You can choose to either remain silent, which means that you're going to cooperate with the other prisoner, essentially, right? You're saying, okay, we're both going to remain silent. None of us are going to talk to the police about the robbery that we did or whatever was found in our suitcase or whatever the situation was, right? And if we both remained silent, then prisoner A, is going to get 2 years. And let's move that down here. While prisoner B is going to also get 2 years. Usually these things kind of, if you want to think about it, have like a little dotted line in between to kind of help with where to put things. So just, and then there's a method to my madness. There'll be a reason why we're doing this in a second. So, all right. Now, what if, the cops, talk to you, right? The law enforcement officers in this foreign country, and they say, oh, you really don't want to do 2 years in our prison. You might not make it out, right? These prisons are really dangerous. It's not like your American prison. And so they might try to get you to confess. And they might tell you that, well, if you confess, we will let you out with just 1 year. And we're going to, it'll be jail instead of prison or something like that, right? It'll be, low security instead of high security or something, right? But if you confess and the other player remains silent, they are getting 8 years in jail. So sometimes you will see this confess as the word think, to think on somebody, right? If you find some like YouTube videos about this, because again, this is a super famous example of game theory and stuff like that here. So if you have any problems dealing with this, obviously you can always email me, but you can also just go on the internet and search for it. And like I said, you might just see think instead of confess. They mean the same thing. And so similarly, person B has the option that they can confess. If person B confesses, they're going to get the 1 year. If person B confesses and person A remains silent, then person A is going to get 8 years. Let's try to make this a B instead of an 8. And now the last thing, right, the last box that we have to, in our foursquare that we have to figure out here, right, is, well, what happens if they both confess? Well, if they both confess, person B is going to get 5 years. And person A is going to get also 5 years. All right, so this is our prisoner's dilemma. And the way in which we solve this is by thinking about the world as two discrete possibilities, right? We want to think about the world as either I'm assuming, so if I'm prisoner A, the first thing I would do is I would just cover up the other half of this matrix, right, of this table. And I would say, let me assume that prisoner B is going to remain silent, right? If I assume prisoner B is going to remain silent, am I going to want to remain silent and get 2 years, or am I going to want to confess and get 1 year? So this is like golf, right? We want fewer years in prison. Lower is better. So the person, if they assume prisoner B is going to remain silent, their best thing to do would be to confess. So we can go ahead and we can underline this to let us know that that's the choice that they would make if prisoner B were to remain silent. And now the second half of it would be for us to cover up that middle part, right? And I'm trying to think of a way that I can do that. I guess this kind of works a little bit. So cover this up. We're not thinking about the remaining silent at all, right? We're just thinking about confessing. What if prisoner B confesses? Me as prisoner A, I have the option of remaining silent and getting 8 years, or I have the option of confessing and getting 5 years. What am I going to do? I'm going to confess, right? Because 5 years is less than 8 years. And of course, there's no reputational effect here, right? There's no whole, snitches get stitches, right? If I go back home, everybody's going to know that I'm a criminal informant and I'm not going to have any friends anymore, right? This is all very, confidential kind of situation. So, given the fact that regardless of whether prisoner B decides to remain silent, if prisoner B decides to remain silent, I want to confess as prisoner A. If prisoner B decides to confess, I want to confess as prisoner A. So as a result, my dominant strategy as prisoner A is to confess, right? So this is what's called my dominant strategy. And essentially, this is my choice of what to do no matter what the other player does. Right? We call the other person in these particular situations players. Game theory, makes sense, right? All right, so now, how do we figure out if prisoner B has a dominant strategy, right? Well, we're going to do a similar thing. We're going to cover up one option and say, well, what if I assume that prisoner A is going to confess, right? So now we're prisoner B, so we're using yellow pen instead. I tried to color code this to make it easy for us, right? And now instead of an underline, I'm going to do an overline, a line above it, because it has to do with prisoner B. So also the underline and overline, like if you don't have colored pencils, you can still kind of keep track of like what is the choice for each person by using an underline for the person A, which is the person to the left, and then using an overline or a line above the words for prisoner B, because that's the person that's above, right? So again, just trying to teach you guys just some quick mnemonics there, just some quick ways to think about or remember this. So if we cover up prisoner A remaining silent, if we assume that prisoner A is going to confess, as prisoner B, I can remain silent and get 8 years, or I can confess and I can get 5 years, right? So what am I going to want to do? I'm going to want to confess, right? Because 5 years is less than 8 years. And I'm going to want to not have a laser pointer and have an actual thing here. Right? So prisoner B is going to get 5 years. So now we go down and we say, well, what if prisoner A has decided to remain silent? What if that's the choice? What if that's the discrete, possible, real-world outcome that we're going to be living in? I can confess and get 1 year, or I can remain silent and get 2 years. What am I going to want to do? Going to want to confess. So now we can take this away, and we can say, okay, and we can maybe highlight this a little bit more, and we can say, okay, I can see that regardless of what prisoner A does, I'm going to want to confess as prisoner B. That's my dominant strategy. So, in this particular situation, despite the fact that both of them, by remaining silent, would only get 2 years each in prison, because of the incentives and because of the known outcomes of their interdependent decisions, what is likely going to happen is this outcome, where they're both going to get 5 years. That's their dominant strategy. So that's most likely what they're going to do. They're going to pick their dominant strategy, and then they're both going to end up here. Now, the next part of game theory has to do with a guy named John Nash, who, if you've ever seen the movie A Beautiful Mind, was one of the main characters of A Beautiful Mind, and was the movie A Beautiful Mind was inspired by him. He came up with this notion of how to do economics and this game theory stuff. And so as a result, there is an equilibrium in game theory that is specifically called a Nash equilibrium. And a Nash equilibrium is a set of choices by players that results in an outcome that neither player unilaterally by themselves wants to change. Now, a Nash equilibrium, in this particular example, and for the most part, this example is one of the only examples that we learn in economics, even in intermediate economic classes, right? So oftentimes students they confuse and think that it's the same exact thing, right? Dominant strategies with Nash equilibrium. They are different things. Sometimes the outcome that results in the dominant strategy is the Nash equilibrium, right? But not all the time. So it is a Venn diagram kind of situation, right? Where, for this particular example, our particular example, right? This is our dominant strategy, the two dominant strategies, and then this is our Nash equilibrium. And so our particular example does fall smack in the middle here, right? Where it's where the dominant strategies come together, right? Where this dominant strategy, laser pointer, please. Where this dominant strategy goes to right here, and this dominant strategy also goes to right here. But I really want to stress that just because the dominant strategies point to that outcome does not make it a Nash equilibrium. A Nash equilibrium results from the fact that if you are player B and you are in this situation, you are sitting in the chair and people have already confessed, you're about to get 5 years, would you want to have unilaterally changed your decision by yourself? Would you have wanted to remain silent instead of confess? Would you or would you not have? No, because then you would have gotten 8, right? So there's no incentive for you to deviate from the strategy that you chose, okay? Similarly, if we asked person A, would they have rather chosen to remain silent instead of confess? They would say the same thing, no, because remaining silent would have given me 8 years compared to confessing and getting 5 years. So in this particular example, the Nash equilibrium is this particular thing, right? The Nash equilibrium for our example here, for the prisoner's dilemma, is going to be confess, confess. That is the Nash equilibrium. Questions on game theory, setting it up, solving it? Okay. So again, the easiest way that I've found to do it is you literally just take your hand and you cover up the screen. Cover up half the choices. And say, okay, what if I assume that they're going to do the thing to the left? What if I assume they're going to do the thing to the right? That's the way that I've found it easy to do this, because otherwise it just kind of gets a little bit overwhelming when you look at everything all at once. Now, I'm sure some of you are like, well, what does this have to do with businesses and oligopolies, right? Well, just like we teach you limits on the way to calculus as a stepping stone, by learning this in this context that we can all understand, makes it easier for us to learn it in the context of an oligopoly.